Hello everyone, in today's discussion, we'll explore the current divider rule, specifically applied in parallel circuits. Our first example focuses on two parallel resistors labeled as R1 and R2. R1 has a value of 5 ohms, and R2 is set at 10 ohms. Our current source, denoted as I, which has a value of 20 amperes. Let's break down the current division in this setup. Okay, here, the voltage across the two resistors are both equal since they are parallel. Let's denote that as V. Let's call the current flowing to R1 as I1, and R2 as I2. So guys, to solve for I1 it is equal to V over R1. But since there is no value for voltage, we will use the formula of total current. Total current I is equal to V over the total equivalent resistance for two resistors in parallel, which is the product over the sum of the two resistors. R1 times R2, all over R1 plus R2. And let this be equated to V, which is equal to I total times R1 times R2, all over R1 plus R2. Then substitute it in the formula I1 is equal to V over R1. So here, R1 will be cancelled out. So I1 is equal to I total times R2 all over R1 plus R2. Then for I2 guys, it is equal to V over R2. Again use the value of V to solve for I2. Here, R2 will be cancelled out. So the formula will be I2 is equal to I total times R1 all over R1 plus R2. We can now solve I1 and I2, using these formulas. I1 is equal to I total times R2 all over R1 plus R2. Substituting the values. I1 is equal to 20 times 10 all over 5 plus 10. So 200 over 15. And that will be equal to 13.33 amperes. I2 is equal to I times R1 all over R1 plus R2. Plugging in the values. I1 is equal to 20 times 5 all over 5 plus 10. 20 times 5 is 100. 5 plus 10 is 15. So 100 over 15. This will result in 6.67 amperes. To check if your answer is correct, just add I1 and I2. It should be equal to the total current. So I1 plus I2, 13.33 plus 6.67 is equal to 20. Meaning your answer is correct. In a parallel circuit, the total current is the sum of the currents flowing through each individual resistor. Remember that the total current of the parallel circuit is divided in each of the resistors depending on their value of resistance. The higher the resistance, the lower the current. And the lower the resistance, the higher the current. Another scenario where three resistors, denoted as R1, R2, and R3, are arranged in parallel, each having values of 5, 10, and 15 ohms, respectively. The total current in the circuit is 10 amperes. It's essential to note that the voltage across parallel resistors remains constant, represented as V. The current flowing to the resistors are labeled as I1, I2 and I3. To solve for I1, it is equal to V over R1. But since the given is not the voltage, instead the total current. So we need to know the value of V in terms of current and the total resistance. I is equal to V over R total in parallel. R total in parallel is equal to 1 over the quantity, 1 over R1, plus 1 over R2, plus 1 over R3. Multiplying the R total in I. So V is equal to I times 1 over the quantity, 1 over R1, plus 1 over R2, plus 1 over R3. Substituting it to the equation, I1 equals V over R1. I1 now is equal to I times 1 over the quantity, 1 over R1, plus 1 over R2, plus 1 over R3, all over R1. Or it can be written as I over R1, times 1 over the quantity, 1 over R1, plus 1 over R2, plus 1 over R3. So it follows. I2 is equal to I over R2, times 1 over the quantity, 1 over R1, plus 1 over R2, plus 1 over R3. And I3 is equal to I over R3, times 1 over the quantity, 1 over R1, plus 1 over R2, plus 1 over R3. So now, we can solve the circuit using the values. The formula for I1 is equal to I over R1, times 1 over the total equivalent resistance of 3 resistors in parallel. For I1, it is equal to 10 over 5 times 1 over the quantity, 1 over 5 plus 1 over 10 plus 1 over 15. R total in the formula is 1 over the quantity, 1 over 5 plus 1 over 10 plus 1 over 15. This can be simplified to 30 over 11. This will be used later in the current divider formulas. 10 over 5 times 30 over 11. 300 over 55. And this will result in 5.45 amperes. The formula for I2 is equal to I over R2, times 1 over the total equivalent resistance of 3 resistors in parallel. Using the values. I2 is equal to 10 over 10 times 30 over 11. This will simplify to 300 over 110. And it will be equal to 2.73 amperes. Formula for I3 is equal to I over R3, times 1 over the total equivalent resistance of 3 resistors in parallel. Substituting the values. I3 will be equal to 10 over 15 times 30 over 11. Simplifying this, it will be equal to 300 over 165. This will be equal to 1.82 amperes. Again to check it, I1 plus I2 plus I3. So 5.45 plus 2.73 plus 1.82 is equal to 10 amperes. Which prove our answer is correct. So that's how we solve a circuit using the current divider formula. Thanks for watching. If you found this video on current divider formula helpful, don't forget to hit the like button and subscribe for more electrical engineering content. Feel free to leave any questions or suggestions in the comments below.